Hello, you're welcome to my YouTube channel. In this video, I'm going to be solving this exponential equation. So we have 5 raised to the power 2x plus 6 is equal to 7 raised to the power of x plus 3. Now let's start with what we have on the left hand side. From one of the laws of indices, if you have a raised to the power x times a raised to the power y, this can be written as what? A raised to the power x plus y. If you notice closely, you will realize that this and these are of the same form. But what about if I want to transfer it to this form? Of course, I can do that. And that's exactly what we're going to be doing right now. So I'm going to rewrite 5 raised to the power 2x plus 6 to become 5 raised to the power 2x times 5 raised to the power 6. Again, if you apply the law of indices, when they have the same base, you're multiplying, you will just add the exponent, and then you have what you're supposed to have. You get this back, right? So this is equal to, I'm going to do the same thing to the right hand side. So it's going to be 7 raised to the power of x times 7 raised to the power of what? 3. Now, all clear and we're good. So the next thing I'm going to do is to collect like terms based on their powers. Let me show you something. Look at this. This is what? X. You see that? What is this? 2x. So based on their power, I'm going to separate the terms. So based on their powers, I'm going to separate the numbers. So what am I going to have? I will say divide both sides by 7 raised to the power of x, so that I will bring it to the right hand side. So this cancels this. But what about 5 raised to the power 6? But let's just go to the next line and write this here. So 5 raised to the power 2x times 5 raised to the power 6 over 7 raised to the power x is equal to what? 7 raised to the power of 3. So what do I do if I want to get rid of 5 raised to the power 6? Again, divide both sides by 5 raised to the power of 6. So basically, this will just move down here if I divide both sides by 5 raised to the power of 6. I hope that makes sense. So I'm going to write 5 raised to the power of 2x over 7 raised to the power of x is equal to what? 7 raised to the power of 3 divided by 5 raised to the power of 6. You see what I've done now? I have now separated the numbers according to their powers. So the one that have algebraic power like this and like this, I just brought them together. So you might be wondering, what am I going to do with this? See what we're going to do next. What do you have here? This is 5 raised to the power of what? 2x. Do you know that I can make this have a base of 25, and I can also do it the same thing here? Notice something. This is 7. This has a base of 7. This has a base of 7. What about if I also try to make sure I have a base of 25 here and here, so that I can now sort of have a common base or common basis on both sides where I can equate the exponent? So that's where I'm going to with all of this I'm saying. Now, do you know that if you have, let's say you have x raised to the power of a, b, this can be written as x raised to the power of a bracket b. You can even switch the powers. You can say ba if you like. That's one of the laws of indices, right? So that's exactly what I'm going to be doing here. Now watch this. It's going to be 5 raised to the power of 2. I'll put a bracket here, x. Of course, if you multiply 2 and x, you get what? 2x. So nothing has changed. All right. So this is over what? 7 raised to the power of x is equal to 7 raised to the power of 3. But hold on. What about 5 raised to the power of 6? What can I do with that? Wait, let me show you something. Do you know I can rewrite it like this? 5 raised to the power of 2 times, this is times dot times 3, right? And when I seclude it like this, I'm going to be having 25 raised to the power of 3. Do you see what I'm saying? Are you seeing that? So this is making sense already, right? No. Let's come here and do just that right here. So it's going to be 5 raised to the power of 2, then 3. If you multiply 2 and 3, you get 6. So nothing again has changed. Okay, I think we're getting very close to our answer. Now watch this. This is 5 raised to the power of 2. Look at this. 5 raised to the power of 2 is what? 25. So I'm going to write 25 raised to the power of x over 7 raised to the power of x is equal to, this is 7 raised to the power of 3, all right, over what? What is 5 raised to the power of 2? 25. So we are making progress with this raised to the power of what? 3. Now watch this. Hold on a bit. See, it has a common power on the right hand side. Here on the left hand side, it has a common word power. Do you know there is a law of indices which is called power of a quotient rule? See, if you have a raised to the power of x over b raised to the power of x, you can rewrite it. This is quotient, a over b, right? Now they have a common power. This can be rewritten as a over b all raised to the power of x. Of course, you can do this. If you want to bring it back to this form, you can distribute this power to a and b, because this bracket already tells you that x should be applied to a and b. So that's exactly what I'm going to be doing to the right hand side and to the left hand side. Am I making progress with this? So let's start with the one on the left hand side. It's going to be 25 over 7 all raised to the power of x, right, is equal to what? 7 over 25 all raised to the power of 3. All right, this is making sense already. But it seems we have a little challenge. What's that? See, this is 25 over 7 and this is 7 over 25. Oh my goodness, they are not the same. Even though you have numbers, the number in the denominator here is the same and as the number in the numerator on the other side, vice versa, but they are still not the same. So you might want to ask, what should we do to make them the same? See, there is a law of indices. Let me just write something for you. Let's say you have a raised to the power of minus x, okay? If you want to get rid of this minus sign, you can write it like this, 1. So you are taking the reciprocal of a raised to the power of x. So it's going to be what? A raised to the power of x. So this and this are the same. Let me extend this a little bit. If you have a over b, for instance, all raised to the power of x, do you know that if you want to change, because I told you if you are bringing a negative sign to the power, you must take the reciprocal of the number without the power. See what I'm going to do now. If I want to bring in minus to x, I am going to take the reciprocal of a over b. It will now become what? B over a. So when I say reciprocal, you have a fraction. Turn it upside down. Basically that. So a over b will become what? B over a, all raised to the power of what? Minus x. You see that now? That's exactly what I'm going to be doing to what we have up there. So let me just take this up and let me take you back to the equation that's just above this. Are we good? So let's go there. Now watch this now. I am now going to rewrite 7 over 25 as 25 over 7, just so that I'm going to have it same as what we have on the left hand side. I hope you are getting value from this. If you are, please make sure you subscribe to this channel, like this video already, and share with your friends and family, so that you would be able to if you do that, you are just going to encourage me to make more videos and, you know, be a blessing to many people. So see what I've done now. I have rewritten 7 over 25 as 25 over 7, but you have to bring in a negative sign to the power, right? You know, I just explained that already. Thank goodness we have the same base on both sides, 7 over 25 here and 7 over 25 right here. So what do we do next? Just equate the exponent. This is an exponential equation. They have the same base on both sides. Equate the exponent. So here we're going to say that x is equal to what? Negative 3, because we have x and negative 3 here. So this is the value of x that will satisfy the equation. But hold on. We cannot just conclude yet. Let's do a quick check. All right, I'm going to rewrite the equation. So I have 5 raised to the power of 2x plus 6 is equal to what? 7 raised to the power of x plus 3. So let's plug in minus 3 into this equation and let's see what it will give us. So this is 2x is negative 3, remember? We just got it. Plus 6 is equal to what? 7 raised to the power of minus 3 plus 3, because x is 3. All right, let's move on. So what is minus 3 times 2? That's what? Minus 6. And then let's come to the right hand side. What is minus 3 plus 3? That is 0. Minus 6 plus 6 is what? Also 0. Okay, so would this be equal to? Let me just put a question mark there. So we're trying to test if it will be equal to. So 7 raised to the power 0. What we're testing is question mark, will it be equal to? Question mark, question mark. So quick question, people. What is 5 raised to the power of 0? From one of the laws of indices, okay, a non-zero number raised to the power of 0 is 1. Let me say that again. A non-zero number raised to the power of 0 is what? 1. So 5 raised to the power of 0 is 1, okay? And 7 raised to the power of 0 is also what? 1. So what we have on the left-hand side is the same as what we have on the right hand side. So we can conclude by saying that the value of x that will satisfy the equation is what? -3. I hope this video was helpful. If it was, please like and share this video. Subscribe to this channel if this is the first time you're coming across this channel or not. And make sure you tell people about this channel so they will also benefit from what we're doing on this channel. I hope to see you when I make my next video. Thank you and bye-bye.